Welcome friends again to the session of sampling. So, in the last session also we were continuing with that. So, in the last session we discussed about the non-probabilistic sampling, basically what is a sample and how do we start the sampling and what is a non-probabilistic sampling, and then we had just started with the probabilistic sampling methods, in which under probabilistic we said there are a few, like for example we started with the simple random sampling, okay, the first simple random sampling, in which we said that every item, right, every respondent gets an equal chance of selection, right. So, that is the beauty of a probabilistic sampling where the biasness is not there, right. So, there is no biasness because everybody is getting. So, in my class, as I said, there are 50 students and I want to pick up any 5. So, I pulled up randomly and this 5 are the people who have. So, there is no bias in my selection process, but yes, one thing is for that there could be questionable whether these 5 are actually adequate or they are justified, because some of them might, all the 5 were students actually who had the lowest attendance in the class, they had never visited the class most of the time. So, in that case this becomes a difficult thing, but so be it. But the objective of a probabilistic sampling is to reduce the bias, right. So, second let us see. So, once we finished that, so the next was the stratified sampling. So, stratified sampling, as you can understand from the name, right, stratified. So, which says there is a word which is itself is a word like strata, right. So, this has emerged from the word strata, right. So, what does a strata mean? The earth is, for example, the crust of the earth, the layer is spread up into different stratas, okay. The atmosphere, we have ionosphere, all these are stratas, right. So, a strata, basically we divide, what is saying, a population, stratified sampling is where population embraces a number of distinct categories, the frame can be organized into separate strata. So, whatever is our population, let us say, now each, let us say, has been divided into several strata, okay. These strata as actually they are completely defining the population, okay. So, sometimes they are called proportional or quota random sampling also, but it is not necessary that it should be proportionate all the time, proportional, it could be disproportionate, right. Stratified sampling is also there. So, stratified sampling is of two types, proportionate stratified sampling and disproportionate stratified sampling, okay. But one thing is there which I will be telling, right, okay, let us see. So, example is, for example, a staff stratified is small service agency, and suppose somebody is using a client assessment of a client wants to assess the quality of service, there he can use stratified sampling to so when you want to make a study, right, about let us say for example a population about its behavior or something, let us say what is the kind of the cigarette smokers, right, the habits of cigarette smokers, right. So, in such a condition a stratified sampling could be used to reduce to increase the accuracy and reduce the cost of a in a study. Now, what it is doing basically, so as I said, the stratified sampling divides the population into several stratas through several variables, right. So, each strata, now each strata, from each strata there would be some representation, right, there would be some representation from each strata. So, let us see what it is doing. So, this is a list of clients, the sampling frame, right. So, from where 3 different kinds of clients have been 3 stratas have been built, the African American, the Hispanic American, the others, okay. The difference between, if you can see, this something looks similar to you like a quota also, right. But here the difference between quota and the stratified sampling is that in a quota sampling you are not using probabilistic method, rather you are using a convenience or judgmental method, right. But in the case of the stratified sampling, the method of selecting the element is a probabilistic method, right, that is the only difference. So, now let us say from each strata there is a representation, okay, and now randomly subsamples are pulled from the each strata, okay. So, when you pull out the strata from, when you have broken it into each strata, and from each strata you randomly select a few samples, right, the few respondents you can say whatever. So, the thing is that you have divided the population into several clear cut stratas, and these stratas are representing right, there is at least some representation, it cannot be 0, that is a very important thing. Okay. So, for example, this is the case of a proportional allocation strategy for a proportional stratified sampling. What it is saying, the size of the sample in each stratum is taken in proportion to the size of the stratum, right. So, suppose in a company there are following staff: male 90 full time, male part time only 18, female full time is 9, female part time is 63. Okay. So, the total is 180. Now, we are asked to take a sample of 40. So, we need only 40 people as our sample. Now, how do we use stratified sampling? Let us see. So, if you go back now, percentage of male full time is total is 180. So, 90 out of 180 was 50%. Male part time was 10%, female full time was 9 out of 180, so only 5%, but female part time was 35%. So, now once we have these percentages, what we do next is, we then for a sample of 40 we take 50% of 40, that is 20 individuals, right, should be male full time, 10 individuals, that 10%, that is 4 individuals should be male part time, which was 18 there. 5%, that is 2 individuals should be female full time, and 35, that is 14 individuals should be female part time. So, stratified sampling, the biggest advantage of stratified sampling is that stratified sampling helps you to bring in involve all the stratas into the study, right, you are not omitting any study, any part of the study. So, finally, this is the scene. Okay. But let me tell you, in a stratified sampling which I have missed out as a slide, is that when you make a stratified sampling, please keep in mind, do not take too many variables. Do not take too many variables. The maximum number of variables one should consider, generally we consider the demographic variables. So, it should be a variable only 1 or 2, right. It is not key, you cannot do more than that, but if you take more than 1 or 2 variables to create your stratas, then what happens is it becomes highly complex. Okay. So, you should avoid, and the other thing is, the number of strata that you make should not be more than 6, ideally it should be less than 6 stratas. Okay. So, for example, 4, 5 and the 6th. Okay. So, we can say male, let us say Indian, male American, female Indian, female American. So, let us say male, let us say Italian, female Italian. So, what I am doing is, if I am dividing the population, I should divide the population maximum up to 6 stratas, because the whole objective of stratified sampling was to divide it into equal numbers, so that you do not have to spend too much of time and effort in getting your results or a proper analysis. So, that itself will be will be lost, that objective will be lost. So, let us not take more than 2 variables, right, at a maximum, and 6 stratas at a maximum, right, 6 stratas. Okay. So, this is what we should remember. So, after we are done with the stratified sampling, so you can understand now, I hope stratified sampling is a very useful sampling, it can be used in most of the research studies, right. So, now let us say the next is systematic sampling. So, as the name suggests, systematic sampling is something, there is a system. Okay. So, something is been done in a systematic order, or let us say what it is saying, it relies on arranging the target population according to some ordering scheme, right. So, for example, in this case there are 6, let us say there are 6 samples, let us say, now consider it as a sample. Okay. Now, I want 3 samples out of it. So, what I can do is, I can either take like every second alternative. So, first I will take this one, then I will leave this, I will take this one, I will leave this, I will take this one. So, I have got 3 samples, right. So, similarly you must have seen when people come from for any census study or something, if they are doing a systematic sampling, they in a colony or something, what they do is they divide the colony into how many, suppose you want, let us say out of 100 you want 10 or 20 samples, right. I think I would be having some similar example. So, you just have to divide that every 20, suppose you need it n is equal to 20, suppose small n is equal to 20, sample you require is 20. So, if you require 20 out of 100, so every fifth element becomes your choice, right. Let us see this. So, the population is randomly ordered, advanced is easy, more precise, okay. Actually this generally it comes after the systematic simple random sampling, right. It is the, if you ask me about if you take a graduation, this is the second one, right. So, let us take this case. Now 100 total number of respondents are there in a library. The study wants 20 out of respondents to be pulled out as a sample study. This population is 100, right. So, if you do that, so every fifth element has to be selected. Now, how it has done? Now, let us see if you go to this. So, 4th, 9th, 14th, 19th, 24th, 29, every 5 gap. So, they have selected 20. So, this is the way the systematic sampling is done, right. The last sampling method is called cluster sampling, right. Under the probabilistic, this is the last one. So, in cluster sampling what is happening, there are cluster sampling is like area sampling basically. So, what is basically a cluster? So, cluster is something like, this is a cluster, right. So, these are clusters. So, the data or the points or the respondents are very similar in nature, okay, are very similar. So, this is cluster A, this is cluster B, okay, let us assume. So, what it is saying, it is like a two-stage sampling, it says. In the first stage, a sample of the areas is chosen. So, as I said, it is also called sometimes area sampling. So, in the second stage, respondents within those areas are selected in a probabilistic manner, okay. So, the population is divided into clusters of homogeneous units, clusters usually based on geographical contiguity or something similarity, you can understand. Sampling units are groups rather than individuals. A sample of such clusters is then selected. So, what happens here is cluster sampling is basically done in there are three ways basically, right. So, one is the we say first stage or one stage sample, one stage, right, then two stage and multi stage and multi stage. So, let us take a very easy example. For example, somebody wants to make a study on the Indian population, right. The government wants to make some study, some understanding about people's tax behavior, why people avoid tax or something, right. So, what it has done, it has got several states and now it wants to select randomly, it pulls out a state, any one state maybe randomly, and then it completely does a study on that population of that state, right. So, when it does it, it is called a one stage, right. So, let us see. So, one stage, two stage, multi stage, right. So, in a one stage all the elements within the selected clusters are included. So, what it says, the elements all the elements within the selected cluster. So, the selected cluster could be the state, could be obviously the state would be large in an Indian condition, maybe the district or the village or the town, whatever you say, are included in the sample. In a two stage sampling, what it is doing is a subset of the elements within the selected clusters are randomly selected. Example, let us see this example. Select all schools, then sample within the schools. First, on the first there are several schools, so you took all the schools and then you randomly pulled out a few of the schools, okay. Then from the schools you take sample students, right. So, first in the two stage what we did, so it is just like the explanation has become more simpler. So, out of suppose we understand the population is or the study has to be conducted on students. So, all schools were taken, out of which randomly some students some schools were selected, and after that again randomly from those schools again students were selected randomly, right. So, in a two stage way we are doing it, right. So, this is something which we say is a two stage sampling. In a multi-stage, only the third stage that goes a little deeper, right, one stage deeper you can understand. So, sampling is complex from the cluster sampling in which two or more levels of units are embedded one in the other, right. So, example it says first stage, random number of districts chosen in all the states. So, from all the states randomly 3 from this state, 2 from that state. So, randomly select the districts are chosen. Then randomly the villages are chosen, after the districts the villages, right, next. So, maybe you have missed by choosing such villages, maybe you might have missed only selected only few villages, right. And the third stage is selecting the houses. Now, when this is all ultimate units, the houses for instance selected at the last step are surveyed. So, this is what is done basically in a multi-stage. So, the multi-stage is nothing but a two stage, only an advanced version of the two stage, you are going little more deeper. So, first stage you selected all the districts or all the states, then then some of the districts, then from some of the towns or villages, and then finally the houses. Okay. So, this is basically the last slide where we are saying what is the difference between the non-probability versus the probability sampling. So, if you see this conditions favoring the use of these two, right. So, nature of research, as I had also said, exploratory, this is conclusive. The magnitude of sampling error, non-sampling error. So, non-sampling errors are like which is not related to the sample exactly. So, here this is when there are larger. So, if it is the non-sampling errors are larger, go for a exploratory study. If the sampling errors are larger, then you go for a conclusive study, then sorry probabilistic sampling, right, sorry non-sampling errors are larger, you go for a non-probabilistic, and sampling errors are larger, you go for a probabilistic sampling. Yes, I am getting slowly tired. Variability in the population, it is homogeneous. So, the when there is low differences, there is small differences in the variability, it is good to go for a non-probability, but if it is high, if the samples are very different from each other, then you should never go for a non-probability, rather a probabilistic sampling. So, that is why I said when in most of the experiments we use the probabilistic sampling, right, method. So, these are some of the things, right. Then I will come from here to the sample size, right. Okay. Now, once you have understood what to use, first we understood whether we will use the non-probabilistic or probabilistic sampling. So, when you write a research paper or when you are doing a study, it entirely now depends upon you, right, what kind of a method you want to use. So, you can select your sample randomly, you can select your sample non-randomly. So, if you want if you feel that no, all the people do not understand this subject, then it is better to go for a non-probabilistic method. But if you feel that everybody has got a equal knowledge on the same subject in your, so for example, students in my class, then I used a probabilistic method. But now the question comes, is what is the right sample size? Okay. What is the right sample size? Now, how do I know what is the right sample size? Is there any method that somebody can tell me? Because everybody when does a research, students even come and ask, sir, what should be the sample size? How many samples should we take? Now, how do I know? You should know about your study. So, there somebody has to be told what is the method. Let us start with the simple methods. The simple method is either you go for a mathematical approach, right, which is we say the confidence interval approach, right, confidence interval approach. So, what is this confidence interval and approach and how it is used? So, let us understand it is through a normal distribution. First, let me explain this, then I will go to the other one. So, this is a normal distribution. So, what is happening is we are saying that if you remember by any chance, if you do not, then you go to the Chebyshev's theorem to understand that. Okay, what is a normal or a Bell's curve we say is this is the point where the mean, median and mode lie, right, and this is not skewed at the moment. Okay. Now, there are 3 standard deviations to the right through the left. Okay. So, 1 standard deviation, 2 standard deviation, 3 standard deviation, right. Now, this standard deviation is nothing but the z value. So, we say if you have seen T test, Z test, T distribution, Z distribution, the Z value that we talk about, the Z value or the Z value is basically that value which is nothing but the standard deviation, you can understand. It is the standard deviation from the mean, that means it is a standardized value, right, it is a standardized value and it is unitless. So, what is happening here? Now, suppose for example, my confidence interval is, suppose for example, I am saying let us say that it, where does it lie basically. Now, at a confidence level of 95%, at a confidence level, the confidence level is basically something like the researcher wants to be confident, right. So, he if he is confident at 95%, we say there is a chance of error of only 5%, right, which is also termed as the alpha basically. Okay. So, okay, let me start from beginning maybe. Okay, let me explain this, otherwise I will finish this first. So, what I am doing here is, so when there is a 95% confidence level, right, the Z value is generally plus 1 plus 2 minus 1.96. So, the Z value for Z for 95% is equal to plus or minus 1.96. Similarly, there is the three most common confidence intervals that we use are 95%, 99% and 90%. Okay. So, you have three different values for them. I think it is 99 is 2.58 and this one I do not remember, we have to check the table I think. So, when this value means what? Now, these are nothing but the standard deviation. So, 1.96 is somewhere here, 2.58 is somewhere here. So, let us say this to this, let us say this to this is where the value falls. Okay. Now, the question comes, ki if I have a 95% interval, what do I mean? So, what do I mean now? When I am saying 95% or 1.96, the Z value is 1.96. So, the area under the curve that falls, and this becomes the complete my acceptance zone. This is my zone of acceptance, okay. And this portion is my rejection zone, okay. So, if the calculated value, if my Z value falls beyond this at a 95% level, suppose falls somewhere here, then my null hypothesis, which I will explain what is a null hypothesis, my null hypothesis is rejected, let us assume that, okay. So, why I am talking about this? Now, this confidence interval method is used to calculate even the n. Now, how it is that? Now, Z is basically equal to calculated as x minus mu, right, x being the observed value, mu being the mean upon the standard error. Now, what is the standard error that also has to be understood? Standard error is nothing but, this is very important. Standard error is the distribution of the sample standard deviation, right. It is a distribution of the sample standard deviation. Now, number of samples were there and their sample means, the distribution of this sample means gives me the standard error, right. So, if the sample error, standard error is less or more, that will have an effect on my study. If it is less, then I would assume that these samples are actually representing the population and they are good samples, that means they are truly representing the population. But if the samples have a high standard error, the distribution is too much dispersed, then we will say there is a problem. So, lower the standard error, better the study, higher the standard error, poor the study, okay. So, let us see how do you do this. Now, this standard error is nothing but this standard error sigma x is equal to sigma upon root over of n, where sigma being the population standard deviation, okay, deviation. Now, if I have this, now can't I change write the new formula? Now, the new formula will now look like, so that means z is equal to, some people say z, some z, so upon sigma upon root over of n. So, if I need n, so that will this will become that means sigma by root over of n is equal to x minus mu upon z, or this is equal to, let us say this is equal to, this implies root over of n is equal to z sigma upon x minus mu, right. This implies n is equal to z sigma square by x minus mu square, or we can say n is equal to z sigma by x minus u whole square, right, at the top. So, if you use this method, and you can see, that means what did I say earlier, if my standard error is low, the standard error will depend upon the number of sample size. If your sample size increases, what happens to your standard error? It goes on decreasing, but if you have a smaller sample size, then your standard error will increase. So, in order to improve the distribution of the sample standard deviation, you should have a higher sample size. Okay. Now, what is that higher? How do you find out? Now, this is the formula. Now, z sigma square divided by x minus mu. Now, x minus mu is nothing but, do not ever get confused by reading books or something, this is simply the precision, right, this is the precision, right. So, what precision level of study you want, that is basically got the x minus mu, right. So, this is how we find out the let us see, now let us go to the slide. What sample size do I need? So, the risk of selecting a bad sample and the purpose of study population size, the risk of selecting a bad sample and the allowed sampling error are the factors which influence this. So, whether it is a qualitative or a quantitative study, that also has an effect. Now, as I said, now this is the population, this is the sample, right, a subset. For example, you see sample size in qualitative studies, you require an in-depth exploration and understanding. So, there a large sample size does not make a meaning. So, when you are doing a focus group, you do not need 100 focus groups, you will maybe need 6 to 5 or 6, 7, 8 something like this, anything right around that. So, if you do an in-depth study which is in a qualitative study, so your number of samples would be pretty less, right, or the number of n is less there, right. So, in a quantitative study, we determine the sample size on basis of, as I said, the level of precision, the confidence or risk, what level of confidence, 95%, 99%, 90%. So, it depends, right. Degree of variability in the attributes being measured. So, what is the how frequently the variables would change, right, what is the behavior of the variables that we are using, that also will determine. Okay. And then finally, external validity. Now, what do you mean by external validity? If you remember, I had explained you in the last session, I believe, external validity is the generalizability. That means, if you have conducted a study, this study should be able to, you should be able to generalize this study across, right. So, tomorrow if somebody else is conducting a study, he can be able to refer, or your study can be used in some other places also. Okay. So, the level of precision is the true value of the population is estimated to be, this range is expressed in percentage points. Okay. So, what is the level of precision? We are saying exactly how precisely we want, right, the information. Confidence level is the probability that a confidence interval will include the population parameter. So, 95% confidence level is selected, 95 out of 100 samples will have the true population value within the range of the precision, right, and 5 will not have. This 5 is what we call the alpha or the type 1 error. Okay. So, this is the variability. So, it refers to the distribution of the attributes. The more heterogeneous the population, the larger sample size is required to obtain a given level of precision. Okay. So, let us take a problem. I think I have a problem. Let us go to this. Okay. Let us go to this one. As I said, using a census, this is not required, because a census is something everybody understands, it is a very costly thing. So, it is not desirable. So, let us see, these are the notations for use for population and sample first of all. So, in population, in terms of mean, we say mu x, this is pi, this is p, right. So, these are some of the notations which you can later on go through it. Now, this is how the confidence interval looks like. The area of the curve, if you can see, for a 95% confidence level is divided into 95 is divided into 0.475, 0.475 because the entire area is 1. Okay. So, this is 0.4 and the rejection rate is here 0.025, here 0.025, it is a two tail test. If it is a one tail test, all the 0.05 will lie either this side or this side, that we will see in the when we do hypothesis. Okay. Now, let us take this problem. Yes, I was talking about this problem. Suppose a student is measuring the boiling temperature of liquid, observe the readings this. Okay. On 6 different samples of liquid. We calculate the sample mean to be this much. If the standard deviation is known to be 1.2 degrees, what is the confidence interval for the population mean at a 95% confidence level? Okay. So, basically we are not in, we are interested in the sample size to calculate the sample size. So, to calculate sample size, what it has done is, if you see, n is equal to the same formula which I have developed here, right. He has used z is equal to 95%. So, 1.95 and this is equal to 22.09. So, to achieve a 95% confidence interval, right, for the mean boiling point with total length less than 1 degree, a student will have to take how many? 23 measurements. So, 22.09, so 0.09 being the 23rd, so is the 23rd measurement, right. So, this is how the sample size is drawn, but let me tell you something else. The easier way to remember is, apart from the calculation, is that if you have in your study, in your questionnaire, let us say 10 variables, please have a general thumb rule is every variable should be having at least 20 respondents or 20 samples. So, if you are having 10 variables, it should be 200 sample size. If you are having let us say 15 variables, then we have 300 sample size. So, this is the thumb rule that we generally use, the number of questions or items or variables whatever you have used. So, multiplied by 20, but all the time it is not possible. So, sometimes we also bring it down, if it is only 10 per question also or 10 per item is also still good enough. So, if you have variables 20, even if you collect 200, it is not bad, right, but going below that is highly objectionable, is questionable. So, when you do a sample size, keep in mind these things and then you can calculate the sample size and then go ahead with your study. But if you do a over sample size, so it is only a waste of money and time, but if you do a poor sample size, as I showed you, the standard error will increase, the sample distribution will have a problem and then the study will be a weak study. So, it is always advisable to have an adequate sample size. Thanks for the moment.